Okay, my presentation is about the zeroth law of thermodynamics, and this law deals with thermal equilibrium, which occurs when there's no net heat flow between two systems. So as you can see in this graphic, this system starts out at 0 degrees Celsius, this one starts at 100, and once they're both 50, they are in thermal equilibrium and there's no heat flow between the two systems. The formal definition of the zeroth law is that if two thermodynamic systems are in thermal equilibrium with a third system, then they are also in thermal equilibrium with each other. An easier way to say this might be to say that if system A is in equilibrium with system C, and if system B is also in equilibrium with system C, then systems A and B are in equilibrium with one another. The most important aspect of the zeroth law is that it gave a formal definition of temperature. So basically, two systems at the same temperature won't have any heat flow, therefore they're in thermal equilibrium. Having a formal definition of temperature allows us to gain all sorts of thermodynamic data measurements. So just as a quick conclusion, you might wonder why it's called the zeroth law. Well, the first, second, and third laws were already formalized and defined with their given numbers before the zeroth law was discovered or deemed necessary. However, the zeroth law was so substantial to the thermodynamic laws that they thought it shouldn't be labeled the fourth because it supersedes the first three, so they decided just to call it the zeroth law instead.